Hi guys, and welcome to the ACE Academy Grade 10 Stoichiometry playlist. In this series of short videos, you are going to learn everything that you need to know in order to ace stoichiometry in grade 10. This video is going to be the introductory video for this playlist or for this course. And in this video, I am going to try to explain and bridge the gap between your previous chemistry knowledge and the current stoichiometry that we are going to do. Firstly, I know that a lot of you guys have an issue with stoichiometry, and that is just because you don't understand what it is and what its purpose is. So in order to remedy the situation that we currently have with this section, in order to allow you guys to see the beauty of this section, I'm going to try to explain the concept of stoichiometry in this video, and I hope you guys find some benefit in it. So the big question is, what is stoichiometry? Why do we need it? Why do you use it? Where does it come from? Simply put, stoichiometry is the maths behind chemistry. That's an important statement. That means in this section we are mainly going to be doing calculations. But in order to do these calculations, you are going to need a certain amount of theory, because without that theory, you're not going to understand what you're doing, and it's just going to make a whole mess of this section. So let's jump into the theory so that you understand what you're doing step by step. In order to get you guys through that front door into this section, I've created a little scenario that I want you guys to think of whenever you attempt any type of stoichiometric question. Let's look at a glass of water. I have it sketched on your screen. Okay, this is a closed system, which is very important, which basically means there's nothing else in this cup of water except for the water itself. That's all that's there. It's pure water, right? We know that water is made up of molecules. So if I zoom into the water itself, I'm going to be able to see the individual particles that make up this water. And those particles are firstly going to be the molecules. Water is H2O, so we have 2 hydrogens and 1 oxygen. That is our water molecule right there. Now, if I were to zoom in further with my microscope, I would be able to see the actual hydrogen atom and the actual oxygen atom, correct? So I might have added an extra step right here, but that's just to show you guys that there's 2 different atoms within this molecule, right? So jumping straight from the molecule into the atom, we know that atoms are made up of protons, electrons, and neutrons. There are 3 subatomic particles that make up the atom. So we are going to be working with the number of subatomic particles. We are going to be working with the number of particles themselves, the individual atoms. We are going to be working with the number of molecules, and we are going to see the relationship that it has within our chemistry. Okay, so let's just go ahead and go over some fundamental quantities that we are going to be using. Now, the first quantity that I want you guys to take a look at is number of moles. Now, keep in mind, this video is just an introductory video, so I'm not going to go into detail in this video. I'm just going to introduce the concept to you guys, and then I'm going to make subsequent videos in order for you to watch so that you understand each one of these quantities in detail. Okay? So, number of moles is where a lot of students get stuck. And that is just because they don't see what it is. So let's look at what number of moles is. In order to get you guys to see what number of moles really is, I'm going to give you a parable. Let's look at a dozen of eggs, right? What is a dozen? We know that a dozen is 12. So I can say that 1 dozen of eggs is actually 12 eggs. Similarly, in chemistry, what we tend to do is we tend to give a name to a certain amount of particles. I mean, when I say particles, it could be molecules, it could be atoms, it could be electrons, it doesn't matter. All of them are particles. But in order for us to work with these large number of particles, we had to approximate and find a certain set quantity that we were able to work with to simplify our calculations. So Avogadro, a scientist from back in the day, decided that 6.02 times 10 to the power 23 particles is equal to 1 mole of particles, essentially simplifying this large number of particles into a quantity that's easier to work with in our calculations. So, like I said, number of moles can be compared to a dozen of eggs. It's interchangeable. All we're saying is that it's a set quantity that we use in our calculations, right? Now let's go ahead and look at the second quantity that is going to be quite prevalent in the section, and that is the mass of individual atoms, the mass of particles, the mass of molecules. Mass is a fundamental quantity. If you go ahead and look at your periodic table, I want you guys to find carbon for me, right? On your screen right now, you can see that I did sketch the element carbon that is found on your periodic table, and I assigned it values from the periodic table so that it's a bit easier for me to demonstrate it to you guys. We know that the top number, or the small number rather, is the atomic number of that element. In the case of carbon, the atomic number is 6, which means it has 6 protons, right? That's what atomic number means. It has 6 protons. It also gives us the position of carbon on our periodic table. We know that the bottom number, which is 12 in this case, is the mass of carbon. But what we did not emphasize to you guys all these years is that that number, that 12, is actually the mass of 1 mole of carbon atoms. 1 mole of carbon atoms will have a mass of 12. That's very, very, very important, right? So when I speak about molar mass, I'm talking about the mass of 1 mole of a substance, and in the case of elements, it would be the number that you see on your periodic table. 12 is the mass of 1 mole of carbon atoms, right? Now, the third quantity that we are going to look at is going to be number of particles, and number of particles and number of moles are heavily related. And that is simply because we can convert from number of particles to number of moles, etc., etc. These are just quantities that make it easier for us to work with the section. Okay? A fundamental point that I'm going to make in this video has to do with the states of matter, right? And this is because when a substance is in a certain state of matter, it affects the way we do calculations. We are able to calculate the number of moles for solid, liquids, and gases in the same way using the same formula, but when it comes to gases, we have an additional formula as well. So taking note of the state of your element, the state of your molecule in a chemical equation will allow you to find and pick the correct formula to use in that situation. Now that I've introduced you guys to what the section is and what we're going to be doing in the section and the quantities that are present in the section, we are going to look deeper into molar mass and see how to calculate molar mass for molecules and how to find molar mass of individual atoms. Now, what I've done is I've created a little exercise for us to do together so that we can understand and grasp this part of stoichiometry in detail. Okay, because molar mass is going to be present in all your calculations in the section, or rather I should say most of your calculations in the section, right? Let's go ahead and find the molar mass for the atoms that I have listed in the first part of this exercise. Grab your periodic table and attempt that for yourself first. You can pause the video, I'll give you guys a few seconds to do that, and then of course I'm going to jump in and do it with you guys. So I've grabbed my periodic table and I'm looking at the elements that I have listed here on the screen. Looking at the first one, we have calcium. If I look for calcium on my periodic table, I would obtain a mass of 40. So I'm going to just write 40 down. If I'm looking at carbon, I'll have a mass of 12. If I'm looking at potassium, which is K, I'll have a mass of 39. If I'm looking at phosphorus, it'll have a mass of 31. And if I'm looking at fluorine, it'll have a mass of 19. So it's quite simple when it comes to us finding the mass of individual atoms. We can simply have a look at the periodic table and take the masses straight from there. But when it comes to finding the molar mass of a molecule, it becomes a bit more tricky. It's still quite elementary to attempt, but if you don't know how to do it, you're going to get stuck. So to find the mass of a molecule, we simply look at the individual atoms that make up the molecule, and we add up the mass of the individual atoms in that molecule. So if I am looking at the molecule O2, we can clearly see that we have 2 oxygen atoms in this molecule, right? This single molecule has 2 oxygen atoms. So simply, I would say 2 times the mass of oxygen, and the mass of oxygen is 16. So simply, the mass of an O2 molecule would be 32. Can you guys see that? If I am looking at the water molecule, which is H2O, we can see that I have 2 hydrogens and I have 1 oxygen. So simply, it would be 2 times the mass of hydrogen, which is 1, plus the mass of oxygen, which is 16, and that would give us 18 grams per mole. Looking at H2SO4, I can see that I have 2 hydrogen atoms, I have 1 sulfur atom, and I have 4 oxygen atoms. So I can simply put this into an equation and find the mass. So it'll be 2 times 1, which is the mass of a hydrogen atom, plus the mass of a sulfur atom, and the mass of a sulfur atom is 32, plus 4 times the mass of oxygen, and the mass of oxygen is 16. So that'll simply be 98 grams per mole. If I am looking at sodium chloride, NaCl, which is your table salt, we would look at the mass of sodium, which is 14, and we will add the mass of chlorine, which is 35.5, and of course we'd get an answer of 49.5. Finally, let's look at CaCl2. If I'm looking at this molecule, I can see that I have 1 calcium and I have 2 chlorine. That means that I have 1 times the mass of calcium, which is 40, plus 2 times the mass of chlorine, which is 35.5, which would give me 111 grams per mole. It's that simple, guys. Until next time, all the best, and I will see you in the next one.